Hello and welcome to Engineers Mindset Academy. So this is the second video on thermodynamics. In the first video, we introduced thermodynamics and we laid some certain foundations that will guide us while carrying out calculations involving thermodynamics. So do well to watch the first video. I will post the link of that video in the description of this video so you can watch for proper understanding. In this video, we are going to be employing everything we learned in the other video to tackle this problem on the board. So let's consider the question. The question says 0.05 meter cube of gas at 6.9 bar expands reversibly in a cylinder behind a piston. According to the law, PV to the power of 1.2 equals constant until the volume becomes 0.08 meter cube. The question says, calculate the work done by the gas and sketch the process on a PV diagram. So in the previous video, I gave out sign conventions to solve any problem involving work done in thermodynamics. And I said in that sign convention, when a system undergoes an expansion process, then it is automatic. The work done must always be positive. And if you look at this question, the question says once again, 0.08 meter cube of gas at 6.9 bar expands reversibly. So automatically, you already know that if you solve for this problem, you should have your work done to be positive. It can only be negative when there is a compression process or when the system undergoes compression. All right. So having that in mind, let's pick out our parameters. 0.05 meter cube of gas. So condition at state 1. So let's pick out the conditions at state 1. Okay. At state 1, we have 0.05 meter cube of gas. Initial volume. Okay. V1 is equal to 0.05 meter cube at 6.9 bar. So initial pressure P1 is equal to 6.9 bar. So it is important for you to always convert your pressure to the main unit of pressure, which is in Newton per meter square. So 6.9 bar is the same thing as saying that pressure P1 is equal to 6.9 multiplied by 10 to the power of 5 in newtons per meter squared or in pascals. Okay, expands reversibly in a piston behind a cylinder according to the law. So we are given a law. The law is PV to the power of 1.2 is equal to constant. So this simply implies that PV to the power of 1.2 is actually equal to what? K, where K stands for the constant. Now, what this means is that the initial pressure and the initial volume, P1 V1 to the power of 1.2 is equal to a constant, and this is also equal to P2 V2 to the power of 1.2. So this simply means that P1 V1 to the power of 1.2 is constant. It also means that P2 V2 to the power of 1.2 is also what? Constant. So this is basically what the law is simply saying. All right. Until the volume becomes 0.08 meter cube. Okay. So the condition at state 2 now. So we are now at state 2. Conditions at state 2. Final volume. Okay. Final volume V2 is equal to 0.08 meters cube. Calculate the work done by the gas and sketch the process on a PV diagram. So notice that when given final pressure is unknown, final pressure was not given, P2 is actually unknown, and we are asked to find the work done, also unknown. All right, so these are the conditions of the system at state 1. These are the conditions of the system at state 2. So I explained all of this in the first video, that a state defines the condition of the system at a given point in time. I also talked about a thermodynamic process, and I said the process is any activity within the system that changes the system from one state to another. So in this case now we have state 1 to state 2, which means a process have taken place. All right. So having these conditions now, we need to find work done. To calculate work done, the formula is given as integral from initial volume to final volume V2 of pressure times change in volume. integral from V1 to V2 times of P dV, where P stands for the pressure and dV simply means the change in volume. So this is how to calculate our work done. But now we need to find the pressure from the given law. So the first thing to do whenever a problem has been given to you, after picking out your parameters, the next thing to do is to find your pressure, and you can only find your pressure from the given law. So from this law, we have two portions of the law. P1 V1 to the power of 1.2 is constant, P2 V2 to the power of 1.2 is constant. Then you look to the given condition. Which of the condition is quite satisfiable to find the value of pressure? Okay, which of them can really satisfy this equation? In the question we are given, that's in the initial condition, we are given P1 and we are given V1. So which means we have P1, we have V1, so we can relate these two. P1 V1 can be equal to what? The constant K. But in the final condition, we have only V2 and no P2, so which means we cannot relate the constant to this aspect. So we only relate the constant with what? P1 V1 equal to K. So that means P1 V1 to the power of 1.2 is simply equal to what? A constant K, since we have sufficient information to find this value of K. All right, now what is P1? P1 was given as 6.9 bar, which we converted to 6.9 by 10 to the power of 5. So this simply means that this implies that K is equal to P1 is 6.9 by 10 to the power of 5 multiplied by V now to the power of 1.2. Now what is V1? V1 is 0.05, so multiply by 0.05 to the power of 1.2. So this simply implies that the value of K is equal to, let's punch this all through and get a value. So 6.9 by 10 to the power of 5 multiply 0.05 to the power of 1.2 simply gives us 18950. So we have 18950 approximately 18950. Okay, so if this is the value of K, not forgetting, the law simply says PV to the power of 1.2 is equal to constant K, which is here. So which means we fall back now and relate these two together to find the value of pressure. So you fall back to it. Now recall that PV to the power of 1.2 is equal to K. This is the law. So this simply implies that PV to the power of 1.2 is equal to, this is now the value of K, 18950. So from here, you can simply make P subject of the formula by dividing through with what? V to the power of 1.2. So this simply implies that our pressure P is now equal to 18950 all over V to the power of 1.2. So this becomes the pressure. So whenever such questions are given to you with a law, first thing, if the law is constant, then it means their initial conditions are the same. This simply means P1 V1 to the power of this is equal to P2 V2 to the power of this and is equal to the constant. They are all equal. Look at the conditions given and see anyone that satisfies this new law, find the value of K and fall back into the original law and place the value of K. That will help you find pressure, because at the end of the day, we need to find this pressure. Once you obtain this pressure, it becomes the pressure in the law. Then you can solve. So we know the value of P now. P is equal to, let me write it out here. P now is given as 18950 all over V to the power of 1.2. This becomes our pressure. Then we can now substitute into the equation for the work done. So if we do that, we are going to have that work done is equal to integral. Remember, integral from V1 to V2. And what is V1? Initial volume 0.05. So from V1 0.05 to V2, and V2 is 0.08. Then we have pressure times change in volume, and this is our pressure, 18950 all over V to the power of 1.2. So we have 18950 all over V to the power of 1.2 times dV, and you have this. So you see how the equation now have transformed. Everything has now become in terms of V. Okay, this is dV, and then we'll have V to the power of 1.2 underneath here. Okay, so from the rule of integration, you always pull out a constant out of the integral sign. From the rule of integration, always pull out a constant out of the integral sign. So we'll bring out 18950 out of this integral. That means work done is equal to 18950 integral from 0.05 to 0.08. I am now left with dv all over v to the power of 1.2. We have something like this. Now, remember from indices, recall from indices that dv all over v to the power of 1.2 can also be written as 1 all over v to the power of 1.2 times dv. This was actually this case over here. Okay, so we can write it as 1 over v to the power of 1.2 times dv. While from indices, 1 all over v times 1 all over v to the power of 1.2 can be written. So this can also be written as v to the power of minus 1.2 times dv from indices. So we simply change the division sign to what bar. So it becomes v to the power of minus 1.2 dv from indices. So we can rewrite this whole term, dv all over v to the power of 1.2 to what? V to the power of minus 1.2 times dv. So keeping this in mind, it means now that this equation now becomes 18950 integral from 0.05 to 0.08 of v to the power of minus 1.2 times dv. We simply have something like this. All right, so with that, it becomes easier for us to integrate that function. All right, so now we are to integrate v to the power of minus 1.2 dv. So work done is equal to 18950. Now, remember from the principle of integration, if I am to integrate x to the power of n, from the rule of integration, what do? You pick out the variable x to the power of n, add 1 to this power, it becomes plus 1 all over, now divide through by this new power, which is n plus 1. So which means if I am to integrate v to the power of minus 1.2, following from this rule, it's still the same thing. This becomes v to the power of minus 1.2. Now you add 1 to the power plus 1 all over the same thing. Now divide through by the new power, which is minus 1.2 plus 1. Okay, so which means this integral is simply going to be v to the power of minus 1.2 plus 1 all over minus 1.2 plus 1. So you put in your limit of integration from 0.05 to 0.08. Okay, from 0.05 to 0.08, and you have this. Okay, so this means work done is equal to 18950 into, this becomes v to the power of minus 1.2 plus 1 gives us minus 0.2 all over, same thing here, minus 1.2 plus 1 gives us minus 0.2, putting your limit from 0.05 to 0.08. Now at this point, what I will do is simply put out 1 all over or minus 1 over 0.2, or simply put out this minus 0.2 over here. Therefore, I'm going to have my work done to be equal to, this becomes 18950 all over. So I'm pulling out minus 0.2 now. It becomes all over minus 0.2. Open your bracket. I am now left here with v to the power of minus 0.2. Okay, from 0.05 to 0.08. Always attach your limit. So we are going to find this division now. 18950 divided by minus 0.2. Okay. All right, so we divide 18950 by minus 0.2, and that simply gives us work done is equal to, now we divide 18950 by minus 0.2, and that gives us minus 94750. Okay, now also from indices, of course we already explained this earlier, v to the power of minus 0.2 can now comfortably be written as 1 all over v to the power of 0.2. Okay, or you can still solve with it like this, but I I prefer to solve mine like this to make it easier for me, but you can also see solve continuously as v to the power of minus 0.2. So this can now be written as 1 all over v to the power of 0.2. You put in your limit, lower limit 0.05, upper limit 0.08. All right, so at this point, you now put in your limits into the values of v. So work done is equal to minus 94750 into 1 all over. So remember, upper limit comes first minus lower limit. So 1 all over, in place of v, we have the upper limit 0.08. Remember, this is v to the power of 0.2, so raised to the power of 0.2. So upper limit minus lower limit. So I still have 1 all over. In place of v, now comes lower limit 0.05. Remember, to the power of 0.2. 0.2. And we have this. So work done is equal to minus 94750 into, let's now obtain what is 1 all over 0.08 to the power of 0.2. So first of all, I will do 0.08 to the power of 0.2, then 1 divided by the answer. That gives me approximately 1.7 minus, next I will do 0.05 to the power of 0.2. Then I'll do 1 divided by the answer, and that gives me approximately 1.8. Okay, I have this. Now, work done is equal to minus 94750 into 1.7 minus 1.8 will give me approximately, obviously minus 0.1. So from here, negative, of course, so I have 94750 multiply. So I have negative 94750 multiplied by negative 0.1. Of course, negative times negative becomes plus. I have 94750 multiplied 0.1, and that simply gives me 9475. So this simply implies that the work done is equal to 9475 in joules. So this becomes the value of the work done. So once again, look in the question. Question says 0.05 meter cube of gas at 6.9 bar expands reversibly, which is why the work done is positive. So I gave earlier in the first video, given the sign convention, that whenever a system undergoes expansion process, then the work done always is positive, and that is why we have the value here for work done as positive. All right. So that is it for the first part of the question. The second part of the question says, sketch the process on a PV diagram. Now, to sketch the process on a PV diagram, we need to find the second value of pressure, because in the question, we are only given the first value of pressure. And you recall the law we stated earlier that P1 V1 to the power of 1.2 equals K. It also means K is equal to P2 V2 to the power of 1.2. Now we know the value of K, we can actually relate these two together, K to be equal to P2 V2 to the power of 1.2, and as such we can find the value of P2 from here. So if we do that, we are going to find that P2 becomes what? K all over V2 to the power of 1.2. And in the question we are given the second volume, okay, so we can use that to find second pressure P2. Knowing the first, knowing the value of K, which is a constant, K was given to us as, we obtain the value here as 18950. So we have 18950, okay, 18950 divided by V2, and in the question, the second volume was given as 0.08 meter cube. So 0.08 to the power of 1.2, not forgetting, to the power of 1.2. Okay, so I'm going to point everything at once to obtain the value for P2. So 18950, I'll start by 0.08 to the power of 1.2. Then I will do 18950 divided by the answer, and that gives me approximately 3.9 bar. Okay, that gives me approximately 3.9 bar for P2. All right, so if I know P1 and I know P2, then I can sketch the process on a PV diagram with the information given. So let's do that over here. All right, Now, a PV diagram is simply a diagram showing relationship between pressure and volume according to the law given in any question. It's simply a diagram showing relationship between pressure and volume according to the law given in any question, and it is always drawn with pressure on the vertical bar and volume on the horizontal bar. So you can have this to be your PV diagram. Okay, this is our volume always on the horizontal bar, and we'll have the pressure P always on the vertical bar. Okay, pressure is always on the vertical bar and P is always on the horizontal bar. So this is a diagram to show relationship between pressure and volume. So let's start from the question. 0.05 meter cube of gas at 6.9 bar. So the first pressure is at 6.9 bar. So we arrange them from, of course, highest to lowest. And if you compare the first pressure 6.9 bar to the second pressure 3.9 bar, which means 6.9 bar is the highest pressure. So you have here 6.9 bar, and of course the lowest pressure is 3.9 bar, which is pressure P2. Okay, so this is P1, this is P2. Again, the initial volume is 0.05 and final volume is 0.08. So 0.05 is quite lower. So we'll have V1 here, 0.05 meter cube, and we have V2, 0.08 meters cube. So let's relate them now. P1 to V1, of course, the initial conditions, 0.05 meter cube of gas at 6.9 bar. This is 6.9 bar, and this is 0.05. This is where they meet. So of course you can keep it. Then again, P2 is 3.9 bar and V2 is 0.08 bar. So you relate the two of them and you have this. This is 0.08 bar. So this is where they meet. You can actually asterisk where they meet. Now, to plot this diagram, it has to be according to the law given to you. The law states PV to the power of 1.2 is equal to what? A constant K. So since this is not a linear law, then it means I can relate pressure with volume to be what? K all over V to the power of 1.2. This means that pressure is inversely proportional to what? Volume. Okay, this means pressure is inversely proportional to volume. As such, the graph is going to be a little bit curvy because of this is volume is raised to the power of 1.2. So it is also not raised to the power of 1, but rather 1.2. So the volume becomes so the diagram becomes a little bit curved in this manner. Now, if it was to be a linear law, then it would have been a straight line graph. So this is actually the PV diagram for that given question. Okay, so the relationship between pressure and volume is that pressure is inversely proportional to volume from here, because P is equal to K all over V to the power of 1.2, and it is not a linear law. Since this is not a linear law, then you have your PV diagram to be in this manner. All right, guys, so that's it on that particular question. In the next video, I will see you with more examples on work done calculations. All right, so if you find this video interesting, please do well to like the video, and of course share your thoughts in the comment sections. Also share this video to your friends, and if you are new to the channel, please you can do well to encourage me by clicking the subscribe button to keep getting updates when content as this drop. I will see you in the next video with another calculation involving work done in thermodynamics. Thanks and cheers.